Most people have heard the dramatic story of the asteroid that wiped out the dinosaurs 66 million years ago. It has become a classic tale in movies and documentaries, a giant rock from space that suddenly ended the age of the giant reptiles. But 252 million years ago, something far more terrifying and complete happened on Earth. Scientists call this event the Great Dying. It was the worst mass extinction our planet has ever experienced. Compared to this disaster, the end of the dinosaurs looks like a small and minor event. During the Great Dying, an incredible 96% of all marine life in the oceans disappeared forever. On land, about 70% of all species were completely wiped out. It was the closest our planet has ever come to losing all life entirely. For millions of years afterward, Earth looked like a silent cemetery rock floating in space, empty, barren, and almost lifeless. What makes this event even more frightening is that it was not caused by an asteroid or a comet crashing from the sky. This was a self-inflicted wound, a catastrophe created by the Earth itself. Today, we are going to explore the deadly trio, the perfect and terrifying storm of events that nearly erased all life. Massive Siberian volcanic fires, toxic purple skies filled with poison gas, and a collapsing atmosphere that left nothing protected. The most powerful predators of that time were the gorgonopsids. These creatures were the size of large bears and had long sword-like saber teeth that could grow as long as a human hand. They were the undisputed kings of the food chain, hunting with terrifying efficiency across the supercontinent. Walking alongside them were the pariasaurs, huge, heavily armored plant-eaters that looked like a strange mix between a hippopotamus and a military tank. Their bodies were covered in thick bony plates and spikes for protection. In the oceans, life was even richer and more varied. Creatures like trilobites, which had already survived 4 earlier mass extinctions over more than 270 million years, seemed almost impossible to kill. They crawled across the seafloor in great numbers. At that time, all the continents on Earth were joined together into one giant landmass called Pangaea. This single supercontinent was surrounded by one enormous ocean known as Panthalassa. It was a stable and rich world that had already survived many ice ages and slow movements of continents over hundreds of millions of years. No one could have imagined that this ancient paradise would be destroyed so quickly in geological terms, in what felt like just a heartbeat of Earth's long history. So, what triggered the end of this world? The answer lies deep beneath the land we now call Siberia in Russia. Around 252 million years ago, the Earth's crust suddenly cracked open on a massive scale. This was not an ordinary volcanic eruption that lasts a few days or weeks. It was the birth of the Siberian Traps, a vast network of giant fissures and cracks that poured out molten magma continuously for hundreds of thousands of years. The scale of this event was almost beyond imagination. The lava flows eventually covered more than 7 million square kilometers, an area bigger than the entire continent of Western Europe. Rivers of molten rock spread across the landscape, burning everything in their path. But the lava itself was not the main killer. As the hot magma rose from deep inside the Earth, it passed through thick underground layers of coal, oil, and limestone. In effect, the planet set fire to its own vast stores of ancient fossil fuels from below. This underground inferno released enormous quantities of carbon dioxide and methane gas into the atmosphere, rapidly turning the air into a thick, suffocating greenhouse blanket. At first, huge amounts of sulfur dioxide gas caused a short but deadly volcanic winter. Temperatures dropped sharply, and the world experienced a brief, lethal period of extreme cold. But once the sulfur settled out of the air, the carbon dioxide took control, and the planet began to heat up dramatically. This brings us to the first deadly member of the trio, catastrophic global warming. Average temperatures across the planet rose by 8 to 10 degrees Celsius. To understand how extreme this was, remember that today's scientists are deeply worried about a rise of just 1.5 degrees Celsius caused by human activity. The Permian world faced a temperature jump that was more than 6 times larger and far more sudden. As the oceans grew hotter, they lost their ability to hold dissolved oxygen. This created widespread ocean anoxia, large areas of the sea where oxygen levels dropped so low that most sea creatures could not survive. The beautiful coral reefs, which were like underwater cities full of life, were among the first to collapse and die. But as oxygen disappeared from the water, a new and dangerous resident moved in: anaerobic green sulfur bacteria. These bacteria do not need oxygen to live. In fact, they thrive when oxygen is gone. As they multiplied in the dead zones, they produced massive amounts of a poisonous gas called hydrogen sulfide, the same gas that smells strongly like rotten eggs. This leads us to the second part of the deadly trio, the rise of hydrogen sulfide. As the oceans became filled with this toxic gas, it started to bubble up from the water and spread into the atmosphere above. Some geochemists believe that the color of the sky itself changed during this time, turning into an eerie shade of green or purple because of the chemical haze. This poisonous blanket in the air then triggered the final and most dangerous part of the trio, the destruction of the ozone layer. Hydrogen sulfide reacted chemically with the ozone in the upper atmosphere, breaking it down and stripping away Earth's natural protective shield against the sun's harmful ultraviolet rays. Fossilized plant spores from this terrible period show clear signs of genetic mutations and damage caused by extreme UV radiation pouring down unchecked. Every living creature on the planet was now being attacked from 3 deadly directions at once: boiled alive by rising heat, poisoned by toxic air and water, and burned by intense ultraviolet light from the sun. There was simply nowhere safe to hide. Not in the deepest oceans, not on the highest mountains, and not even in the air itself. The once vibrant world had become a silent, cemetery planet. In the rock layers from the early Triassic period that followed, scientists have discovered what they call a fungal spike. During this time, the number of fungal spores in the sediment far outnumbered normal plant pollen. The only things that seemed to thrive were fungi and scavenger organisms that fed on the endless mountains of dead trees and rotting animal bodies. Yet life on Earth is incredibly stubborn and refuses to give up completely. The mighty gorgonopsids, the powerful kings of the Permian, were completely erased from existence. But a small group of their relatives, the cynodonts, managed to survive. These animals were small, rat-like creatures that lived in burrows. Their tiny size, low need for food, and ability to hide underground became their ticket to survival through the worst times. From these few seemingly insignificant survivors, every mammal living on Earth today, including humans, would eventually evolve over millions of years. At the same time, another group of lucky survivors called archosaurs took advantage of the empty landscapes. They would later evolve into the dinosaurs that would dominate the planet for the next 150 million years. The Great Dying was not just a random accident in Earth's history. It was a powerful lesson showing how a planet's climate system can reach a point of no return, where small changes suddenly trigger a chain reaction that becomes unstoppable. If you enjoyed this deep journey into one of the darkest chapters in Earth's history, please hit the like button, subscribe to Science Etherics, and turn on notifications so you never miss our next exploration into the forgotten edges of science and history. In the next video, we can dive even deeper, perhaps into how life finally recovered after the Great Dying, or compare it with the other 5 mass extinctions, or explore what the Siberian traps can teach us about modern climate risks. Let me know in the comments what topic you want to see next. Thank you for watching. Stay curious, and remember, the stones have stories to tell if we are willing to listen.